Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have completed the chapter Reflection of Light. Today, we are going to start a new chapter, and it is propagation of sound waves, or in other simple words, you can only make heading as sounds. Okay, so let us discuss about sound. So take out your pen and copy, and please take down the important notes. It will be easier for you to understand the concepts. If you write, your understanding becomes better. Okay. So let us make heading. Today there is a new beginning, and it is chapter which is known as sound. Okay. So I hope all of you are able to hear my voice. So when you are able to hear my voice, what actually energy is being transmitted to you all? It is actually the sound energy that is being transmitted to all of you. Okay, so so you can very easily say that sound is that energy which is being transmitted from one point to another point when you are able to hear something, listen something. Okay, so what can I say? That sound. So while defining sound, so first let us come to the definition of sound. So while defining sound, can we say something like that sound? It's obviously a form of energy. Form of energy. Okay. So sound is a form of energy. Fine. Now, what else can you say about sound? It's a form of energy that is produced whenever a body vibrates. So it's a form of energy produced, we can write it in short like this, produced by vibrating bodies. Okay, vibrating bodies. And what impact does this form of energy have on our life? It produces the sensation of hearing. So it produces the sensation of hearing, sensation of hearing. Okay, so this is how we can define sound. Okay, so it's a form of energy which is produced by vibrating bodies, and it produces the sensation of hearing in our ears. So these are the basic points that you must remember about sound. So whenever a body vibrates, in some cases it may be seeming that a body is vibrating, but you are not able to hear anything. That may be possible. We will be discussing that why sometimes we see a body vibrating very fast or say very slow, but we do not hear any sound. Say for example, when you are moving this pen like this, it's definitely moving, it's vibrating. So vibration is what? It's to and fro motion. If we consider what is vibration, so vibration is nothing but to and fro motion of a body. So vibration can be defined as the to and fro motion of body, that is vibration, isn't it? So if I consider that this pen is moving to and fro, what it is doing? This vibrating. Now this vibration, as I have said, that vibrating body produces sound. So are you able to hear any sound when this pen is vibrating? I think no, and even I am not able to hear this sound produced by this moving pen. So why it is like this, that sometimes body moves very slow or very fast, but we are not able to hear anything? It is because there is a limitations or the limitations of our ears. Okay, we cannot hear everything that is vibrating. So it's an important point that you must remember. Okay, so if you want that, yes, sir, how can you say that vibrating bodies produces sound? Then definitely you can take a rubber band, stretch it between 2 points, and if you just pluck it slightly, you hear a bowing sound whenever the rubber band starts vibrating, and the sound slowly decreases and stops when the rubber band stops vibrating. So this simple experiments or simple activities demonstrates that vibrating body produces sound. Okay, but not all those bodies are vibrating we are able to hear all those sounds. Sometimes we are not able to hear certain vibrations. Okay, so we will be discussing that later on. Now then how this sound is actually propagated, how the sound is actually propagated. So first of all, you must try to understand that the sound, when it propagates, it requires a medium. So sound for its propagation requires definitely a medium. Now, so sound propagation, so propagation of sound requires a medium. Sound requires a medium. Okay, this is very important, because without a medium, sound cannot propagate. So when you think of certain situation like this, that if two persons are standing in space and they are talking, they are moving their lips, their voice box are vibrating. How do we produce sound? When we just push out the air from within inside our body and the air comes out through the windpipe, it vibrates the voice box and as a result sound is produced. So can you understand that when such a person, when two persons say they are standing in the space and they are talking, they are actually producing sound, but the sound of one person cannot be heard by the other person. So sound requires a medium, and this can be demonstrated by a very simple experiment. I think it is given in the book. Yes, and the experiment shows that you take a bell jar. Okay, you take a bell jar. So this is a bell jar. Okay, and within that bell jar you keep a bell. Okay, within the bell jar you keep a bell, an alarm bell. Okay, so if an alarm bell, say a phone or say alarm clock is kept here. So alarm clock has been kept here. Okay, this is the clock, so it's kept here, and the alarm has been set at a certain time, and it has been kept within the bell jar. So when the bell jar is normally kept, it contains air inside it. Now when the alarm clock starts producing the alarm, you can hear that sound of alarm from the outside of the bell jar also. But if by somehow we can take out all the air from this bell jar setup using a pump and create a vacuum here, so we are just evacuating all the air from the bell jar and creating a vacuum in here. In that case, what is happening? So after that, if you set the alarm and the clock starts producing the alarm sound, it is seen that the clock is vibrating. It can be seen that the clock will be vibrating within the bell jar. But as you have taken out all the air from the bell jar, it is observed that no sound is heard from the outside the bell jar. And we can do this situation. We can make vacuum inside the bell jar using a vacuum pump. We just suck out all the air, and the air is sucked out, and then the vacuum is created there. Under that condition, if you just set the alarm bell and if you start the clock starts producing the alarm sound cannot be heard from the outside. It will be seen that yes, clock is vibrating slightly, but the sound will not be heard from the outside. So this simple activities, this simple experiments proves that sound requires a medium. Without a medium, sound cannot just travel from one place to another place. So when you are thinking of that sound requires a medium, a material medium, so definitely there must be some properties of that material medium that produces sound. So what are those properties this medium should have so that a sound can travel? So when sound is traveling through a medium, what are the properties that particular medium should have in order to that sound can propagate through it? The first point that comes to the mind is that the medium particles should be elastic. So medium particles should have elastic nature. Medium particles should have elastic nature. So this is the first point. Why this elastic nature is required? You know what is elastic? What is elastic material? A material which when deformed regains its original shape when the deforming force is removed. So should have elastic property. Okay, so should have elastic property. Okay, this is the first point that the material medium should have. And what is the other property that it should have? It should have inertia. Okay, so that the particles can carry forward the mechanical energy. Okay, should have inertia. So the medium particles should have inertia. medium particles should have inertia. So these are the two properties that should have inertia. So these are the two properties that the medium particle must have so that sound is able to travel through that medium. So remember these two points. So these are very much important. Why? Because when you will be understanding that how sound is being propagated through medium, then you will be easily able to understand why these two properties are essential. Now see how sound is traveling. Say when I am talking, how the sound is reaching. Say I am talking and in front of me there is another person and the person is able to hear me. Why or how the person can hear me? When I am talking, my voice box vibrates and the sound, something sound or disturbance is created. That vibration, what happens, causes the surrounding air particles to vibrate more randomly. In general condition, when I am not talking, at that instant the molecules of the air are vibrating at a certain frequency. Now when you are making a sound, the additional energy is being produced, additional energy is being formed, mechanical energy is formed from my voice box. Okay, actually it is energy cannot be produced, energy is being converted from my body energy, chemical energy, to that form. Now this energy, additional energy which has been converted from one form to the mechanical form, what happens, causes the surrounding molecules to vibrate more rapidly, and as a result the more rapid vibration is being transmitted from one molecule to another molecule. So it's something like this, that you want to distribute some bunch of copies in the whole class, you just pass on the copy from one student to another student. The student takes his or her individual copy and passes the rest of the bunch to the next student. Like this, the material is being, the energy is being transferred from one particle to another particle without the particles itself or themselves getting displaced. And like this, the particles vibrates, it collides with the neighboring particles more violently, and as a result the extra energy is being transferred from this particle to the next particle, then from the next particle, then another next particle. Like this, these vibrations, the extra energy is being carried from one particle to the another particle step by step, and slowly it reaches the air particles near the ear of the listener. And as a result, when the particles near the ear of the listener vibrates more randomly, what happens, it hits the eardrum with a certain extra energy, and this causes certain kind of sensation near the in the auditory nerves. We know that our eardrum, ear membrane are connected by nerve to the brain, so that auditory nerves vibrate, catch up the sensation, extra energy, and then take it to the brain, where the brain interprets it as a certain sound, and we are able to hear. We are actually able to hear and judge what that sound is. So in this way, sound is basically traveling. Okay, so in today's class we will be stopping here. In the next class we will be continuing from here, and we will be discussing specifically how sound is being traveling. We will be discussing about compression and rarefaction, and in details what is longitudinal wave and transversal. So we will be discussing all these things in the next class. So till the next video, please do study well. If you have any query, mention it in the comment box. We will be happy to solve your problem. Thank you. Goodbye.